Hey guys, this is Ulrich from Nostalgicmathematics. Welcome to our MID Integration B 2022 series. Today we turn our attention to the problem 3 of the finals. We will compute this integral. If you are new here, do not forget to subscribe. So we want to compute this integral I. This integral can get frustrating if we don't have the right ideas. The key here will be to write this integrand as a polynomial of e to ix, because we know how to integrate a monomial of e to ix over an interval of length 2 times pi. But before this, we should make a few observations, because since this number ends by 50, it is clearly a multiple of 50. And we try and we see that this is 50 multiplied by 201, as here. And we may be trying the same for 51, and bingo, that fits. Interesting. So we can have the pattern of this ratio here. Actually, this ratio have the form sine 201z over sine z for z equal 50x here and z 51x here. So we focus on sine nz over sine z. We have this because actually this ratio is 2 times I sine nz over 2 times I sine z. And 2 times I sine z is this difference. Do the same thing for the numerator of this. Next, we factor here e to negative I and z. And also we factor e to negative iz to have this. So we just simplify the first term here to have this. And we read a little bit this to recognize the sum of a geometric series. And next we have this identity. So for n equals to 201, we have this relationship. It is quite interesting because we are getting near to a polynomial of e to iz. But we are still to manage this term, cosine 22x. So we just have to notice that I is the real part of this order integral s, and that's good. Now, let's recall what we have here. So we can rewrite this both for z equals 50x and z 51x to have this. So we have this multiplication. We just rearrange a little bit. We know that here those exponents will sum each other to have this, and we write here because we pick up one term here, another one here. So we have all these terms for a couple KL between 0 and 200. Next we have this one. Since these exponents had each other, we will have this. Actually, we just have to add 22ix to this exponent to have this. It is interesting. Again, we can push this exponent into the exponent of the sigma of the sum to have this. It is quite interesting now. Just recall what we were saying in the beginning. This integral, we know how to handle it. Because for n equals 0, we have 2 times pi. Because this is the integral from 0 to 2 times pi 1. It is 2 times pi. But when n is not equal to 0, we know that the actual derivative of this is going to be the same exponent here divided by 2in. But from 2 times pi to 0, it is the same value, so this is going to be 0. So that's where it can become tricky. So when you have to integrate this sum, we only have to count the number of times this term equals 0. So this term is 2 times pi if 50k plus 51l minus 9089 is 0. So if we know how to count the number of couple KL between 0 and 200 such that 50k plus 51l equals 9089, then you have the solution. And this integral is going to be 2 times pi multiplied by this number of solutions, t. So that's what we do next, using a little bit of number theory. Now let's pick up a couple KL between 0 and 200 such that 50k plus 51l equals 9089. We're going to use congruences. It means that 51l is congruent to this number modulo 50. But 51 is congruent to 1 modulo 50. So this turns out to be L congruent to 39 modulo 50. So L we write as 50m plus 39 for a positive integer m. Next, we replace into this original equation to have this. So we just group the multiple of 50 and we just push this multiplication to the right. And this multiplication is going to be 1989. And we have this new equation. We can simplify by 50 to have this. And then it is straightforward. Because here, 51m should be less or equal to 142. So it implies that m is less or equal to 2. Now to sum up, we know that here, from here, k is going to be 152 minus 51m, but L is 50m plus 39. And m is going from 0 to 2, so we have 3 values. So it means that S is 2 times pi multiplied by t, and t is 3. So S is 6 times pi. But since S is real, S is also I. Notice that, remember that I is the real part of S. So I is also 6 times pi. And we have the answer 6 times pi. And that's all. Thank you for your attention. Again, do not forget to subscribe, like, share, and post your comments. Bye.